Well, we're moving on. We're now at lesson 13D, and it is wait, there's more. In this lesson, we continue to improve our design of an observational study that your college is planning to conduct about the average body mass index of its students. We're going to try to improve the results that we got back in lesson 13C. Since the last lesson, two important facts have come to our attention, or come to the attention of the administrators of this study. 60% of the students at the college are female, and females have lower BMI on average. These facts are causing them to reconsider how to gather the data. The college administrators are concerned that a simple random sample may not be representative of the student population. So question one, how could a representative sample of students be collected that addresses the additional concerns? Hit pause, jot down a couple of your thoughts, look at the objectives, read a little bit more, and then come back and we'll talk more together. So one approach on question one, how can a representative sample of students be collected that addresses the additional concerns, is one approach would be that we could still do random because we need to, but this time in our random selection, 60% could be female and 40% could be male to better represent the campus population. So the objectives for this lesson are that we will understand that in observational studies, representative samples are used to make inferences about populations. Stratified sampling can generate those representative samples. Stratified samples tend to yield statistics with smaller errors than just the plain old random samples. So by the end of this lesson, we're going to be able to create and implement a stratified sampling process for generating a representative sample. It's a good time to grab some more cards, flashcards, or a glossary or Google Doc, because it begins to tell us that a simple random sampling is often used to generate a representative sample to address a research question or hypothesis for an observational study. Stratified sampling is another method often used when the overall population has subpops that may have different characteristics. So make sure you're writing this on your stratified sampling card. So with this stratified sampling, researchers divide the members of the population into its whatever you're wanting to divide them into. Some homogeneous, logical, appropriate, subgroup, subset, whatever you feel needs to be represented in this population or the sample for the population. After you divide the members of the population, then random samples are taken from each of these groups, but there's more, according to each group's percentage of the overall population. Like just a while ago, we heard that 60% of this population is female. In our observational study, in our observational study about BMI, on average, females tend to have lower BMI than males. So it makes sense to make sure the population is divided into females and males, to be sure that each subgroup is represented properly in our sample. Another population division that might be important has to do with age. Young adults have lower BMIs on average than older adults. The idea is that you start to think about subgroups and how they may be underrepresented, and you need to do a stratified random sampling so that these groups are represented right or well, so that you can get better results with your study. By running an analysis of the school's registration records, we find the student population consists of the following percentages. Females under 30, so we have groups, still on the white. We have groups, and then we have the percentage. Females under 30, females 30 years and older, males under 30, males 30 years and older. In the table on the previous page, the entire student body of 540 community college students is listed again, with the information this time about age and gender added into each entry in parentheses. And then they're explaining what's going on in this very large piece of data, or collection of data. Consider student ID 61 is at the top of the second column, and you see this information here. The record's going to tell us that this is student ID 61. The BMI is listed second, and then they are female and they're 30 years old. So this is what it was saying on that last page. You have all of these pieces of data, and they were talking specifically about this piece. It is student ID 61. The BMI is listed second. Then it tells you female, 30 years old. Once again, you need to go ahead and hit pause, work on all of question 2 by yourself, and then come back and let's walk through it together. Question 2 starts by saying, once again, you will select a sample of 20 students. Keep in mind how we did it in the last lesson. Keep in mind what's going to be different this time, because this time we're going to stratify, we're going to do the stratifying to represent the 4 groups of this study. Part A, how many of each group should be present in our representative sample of size 20? Round your values approximately and be sure that we get a total sample size of 20. Create a table in your notes like the one below, but containing enough rows to hold the number of students calculated for each category. So if we're going to have 20 students, and I'm looking back at the 2 screens back when I was looking at the percentages, I'm going to start with the one that says females under 30. So female under 30 is 38%. I'm going to take 0.38 times 20, and I get 7.6. I'm going to call that 7, or I'm going to call that 8. Right now, I'm going to go ahead and call that 8. Then the next piece, females 30 years and older. That percentage was 22. So I've got 0.22 times 20, and I get 4.4. I'm going to go ahead and call that one, 4. Men less than 30, looking at the chart, males under 30 is 34%, times our 20, I get 6.8. I'm going to go ahead and call that one 7, but we're going to go add these numbers back up and make sure that we have 20 when I finish the last one. Males 30 years and older, that would be 6%, so I'm doing 0.06 times 20, and I get 1.2. I'm just going to write 1 down for this one. So the first 2 would be 12. 12 plus 7 is 19, and then 1 more gets us 20. So we have our 20, and that's part A. Part B says create a table. So in your notes, you're going to need to create tables that are pretty long. And in the women under 30, you're going to need to write 1, 2, 3, 4, 5, 6, 7, 8. And for women greater than or equal to 30, we are going to have 4 of those. So you write 1, 2, 3, 4. And then 7 here. And then 1 here. Reading part C. It asks us to pick an arbitrary starting point in the student ID table and circle it. Look at the student's BMI and write it down under the appropriate column heading. Move to the right in the table and circle that entry. Again, look up the BMI for that student and record it in the appropriate column. Continue until a category column fills. In other words, once you get 8 on this column, you are done. I don't care if you come up with 20 more women under 30. You don't write them down. This is a stratified random sample. When this column is filled, you are done. I don't care if you come up with more of them, you are done. 7 here and 1 here. When you get these appropriate 20, we're going to keep doing some more information, but it says further data values for that category should be ignored. When every category is filled, you are done. Our answers are going to be different. We're going to be all over the place, but notice what it asks us to do. Pick an arbitrary start point in the student ID table and circle it. Look up that student's BMI and write it down under the appropriate heading. Move to the right in the table and circle that one. Look it up. I'm going to start there, get us going, and then I'll pause and do the 20 with the recording off. The directions ask us to start back at our table that lists the IDs in random order. So I'm going to close my eyes, run my hand around the tablet and point to something. And what in the world did I point at? Let's see if I can erase. Right there, 399. So I have randomly started at 399, and now it wants me to go back to the big table, pull the data for student 399. I'm pulling the BMI and whether they're woman, female, male, and the age, and then I'm going to put it in the appropriate place in my chart. Student 399. This is mine, but watch mine and then do yours. So now I'm looking at the big printout. I'm looking for 399. And I found it, 399. So I'm going to go to my chart and put that the BMI is 26.7, 26 and 7/10, but I'm going to go put it specifically in the female over 30, 30 and over column. So in the female over 30 and over column, I'm going to go put a 26.7. So in my female over 30, I'm going to put 26.7. Got one done, I've got 19 to go. So now I'm going back to, let me see if I can just pull it up. I'm going back to, nope, not that one. Nope, it should be on pause so you don't have to hear this. Okay, we're looking for that one. And so the directions said, once we get that, then it asks us to continue going, circle that entry, look it up, and then continue until a category fills up. Further data values, I thought somewhere here on here it said go to the left or go to the right. Be sure total sample calculated. I thought they told us to go to the right. Write it down. Move to the right. There it is. Move to the right in our table. So let me undo so I can see what's next. Moving to the right, I now go to 146. I will go to 146 back to these columns over here. They're just pretty ugly because I've got them spliced all over the place. So 146, it's not on that one, and it may not be on the other ones that I've cut. 146, nope, I gotta go cut another one. So what I'm going to do is I'm gonna go look for my 146, and then after the 146, then I'm gonna go look up 428. Whatever it is, I'm gonna document it on my table. I'm gonna keep going and going and then going. Remember, while I'm going on this list, once I've reached 4 in this one, 8 in this one, 7 in this one, and 1 in this one, you do not put any more. I don't care how many more you come across in your random table or your list of BMIs using your random number generator. You stop. You only fill up 8 because remember we're doing a stratified random sample using only the percentages based on the demographics of the school. I'm going to hit pause, go fill up my chart. You fill up yours, get practice doing this so that your mind and fingers are getting to know what a stratified random sample is. So I want to touch base with you in the middle of me gathering my data. Notice that where I am, let me show you my random number generator. I'm doing what it asked me to do. I started at a random number and now I'm going to the right and I keep going to the right. When I looked up 175, student 175 ended up being in this column. I wrote it down, but for no use. I can't use that number. This column is done. Any more females under 30, I just have to go find another number and keep going. I still have places to fill up under women over 30, men less than 30, and I'm done with men greater than or equal to 30. So I'm going to keep looking for my random numbers. I'm going to probably hit many at this point that are going to be numbers I won't use, but I'm going to keep going as I am right here. My next number to try is 328. So I'm looking at my big chart over here, 328. It's a female over 30, so I can use this one. So I'm going to go back over here, and we're at 29.9. Well, that one's now done. This one's done. No more here. So now I'm just looking for men less than 30, but I still have to go random. So looking at 42. Person 42 is female. Moving on. 315. 315 is 315 is female. Moving on. 156. And I'm going to keep doing this. Another female. 451. I'm going to keep going until I find males under 30. So looking at 451. 451 is a 20-year-old male, so I can use this one. The BMI was 27. So that means I've got 2 more to go. I'm going to hit pause, go find these, no matter how many it takes me, and then I'll come back and we'll finish this lesson. So I finished using all of my random numbers. It took several more, keeping on going, and more than 20 to come up with my complete list of the stratified random sample. So now we're going to pick back up at question number 2, part D. It says compute the mean BMI for this random sample of 20 students that I have now picked using the random number generator and applying it to the stratified random sample piece. I'm going to go calculate my mean. You calculate yours, and it is telling me that all of us should be darn close to 27. So I'm going to hit pause, go calculate my mean, and I'll come back and let's compare. So excitedly, I calculated my mean. I added up all of the BMIs divided by 20, and I got 27 and 1500ths. We should all end up being around 27. Part E says a statistic is a summary from a sample. A parameter is a summary value from the entire population. And your answer to Part D, is your answer a statistic or a parameter? And since this is coming from a sample of the 540, it is sorry about that, it's a statistic. Part F, the absolute error in a sample mean is the absolute value of the difference between the sample mean and the population mean. It is the absolute value of the difference between the sample mean and the population mean. The population mean, they know, is 27. So I got 27 and 1500ths, and so I'll subtract the population mean. That gets me negative 1500ths, but the absolute value is 1500ths. And then it says compute this of my statistic and record it here and on the board in the classroom. So the piece that we're going to miss by being an online class is we're not going to be able to record all of these on the classroom board together. So question 3, since we are online and not together, question 3 is going to have to be just a lot of discussion. In the previous lesson, your group computed a sample mean from a simple random sample. What was your mean and absolute error from the previous lesson using the simple random sampling? I didn't write mine down. I was 25 something and I was off about 2 something. It says record your answers here and then record your absolute error. That would be the part I was off on the board in the classroom. So as you look at yours, what you got from last lesson from 13C should be much further away from 27 than what you were when we did the stratified. And so you can look not only at the mean you got, but you can also look at the absolute error. Then Part B says which mean had a larger error. The one that I just calculated was 27 and 1500ths, and I was off by like 15 cents, not 2 whole dollars. And so it says which mean had a larger error. And it should be, in your calculations and anyone who does this, almost every time, it's going to be the larger error comes from the simple random sample, not the stratified. because the stratified is getting closer to the population percentages, the subgroups. Part C, share your absolute errors with the class, and then I'll just have to tell you what happens. It says, so what is the average absolute error among all the groups? So in other words, if we were all sitting in the classroom together, we would take all of our simple random sample errors, and then we would take all of our stratified random sample errors. We would take an average of the errors that we got from 13C, and then we would take an average from the errors that we got in the lesson 13D doing the stratified random sample. And then the question is, what is the absolute error among all the groups? Well, I'm sorry, that's what we would do, is the 13D and the 13C averages. And then part D, and you don't even have to do the average to tell me this answer, is the mean error smaller for the stratified random sample or just the random sample from the last lesson? And it should be, and most every time in class it works out this way, that the average error on our stratified random sample is much closer to the mean, much closer to the original, is a much better study than just doing a random sample. And yes, the answers vary. This is real life, it's messy data. But the big part to glean from this is that there are two types of samples that we've just looked at. One was random, one was stratified random. You need to know how the random is calculated and what it's all about. Same thing with the stratified, and that the stratified is going to get us a much closer picture to the real or true mean of our population. This completes lesson 13D. You know the drill. Go look at your syllabus. See if you have more lessons to do this week. If you do, keep on going. If you don't, do a happy dance, and I'll see you next week.